Hello class, in this video I'll be showing you how to determine the intervals in which the graph of a function is increasing or decreasing. Let's begin. In example 9, we want to determine the intervals in which the graph of the function f of x is increasing and decreasing. Before we start, we want to determine the domain of the function. Since f of x is a polynomial function, the domain of f of x is all real numbers. Now I'm going to find the critical numbers of f of x. To do this, we need a derivative. So by applying the power rule, we have the derivative of f is equal to 4x squared minus 4x minus 3. We're going to set the derivative equal to 0. And then factor the trinomial. So the trinomial factors as the quantity 2x plus 1 times the quantity 2x minus 3. So we have x is equal to negative half and x is equal to 3 halves. Since both of these numbers are in the domain of f, we can conclude that they are critical numbers. Next, we need to determine the values of x that make the derivative undefined. In this case, the derivative is a quadratic function, so the derivative is defined for all values of x. This means that there are only two critical numbers, one at x is equal to negative half, and another at x is equal to 3 halves. Now to determine the intervals in which the graph of the function is increasing, I'm going to create a number line. And on this number line, I'm going to place the two critical numbers. Because at these two critical numbers, the derivative is equal to 0. So now we have three intervals. And what we're going to do is pick a number in each interval and substitute it into the derivative. If the derivative is positive, then the graph is increasing in the interval. If the derivative is negative, then the graph is decreasing in the interval. I'm going to start with the interval that's less than negative half. I'm going to choose the number negative 1. The derivative at negative 1 is equal to 5. This is clearly greater than 0. Next, I'm going to choose a number between negative 1 half and 3 halves, and 0 works just fine. The derivative at 0 is equal to negative 3, and that is clearly less than 0. And finally, I'm going to pick a number that's greater than 3 halves. I'm going to choose 2. So the derivative at 2 is equal to 5, and that is also greater than 0. So it looks like there are two intervals in which the graph of the function is increasing, and one interval in which the graph is decreasing. So the graph of f of x is increasing in the intervals negative infinity to negative half and 3 halves to infinity. The graph of f of x is decreasing in the interval negative 1 half to 3 halves. And we are done.